Good morning, everyone. Thanks for joining here. Pleasure to be here with all of you today to talk around how we are trying to build self-service ingestion at Autodesk, leveraging Airflow as a workflow tool. Yeah, just a quick overview on the Autodesk if you're not aware of it. It's a design and make company. We build architecture, engineering, and construction kind of products along with product design, manufacturing, and also a media and entertainment side of it. Been there in the industry for almost 40 plus years. Started in 1982. Yeah, of course, headquartered in SF itself, close to this hotel, one market. We are around 14,000 employees at this point of time with revenue of 5 billion. Out of that, almost 20% is spent on R&D. That emphasizes our R&D focus, right? We are into subscription-based model lately. That's how most of our revenue is coming as well. So a quick agenda, how I'm going to cover. I'll try to walk through how our data platform has evolved within Autodesk, like any other companies as well. The challenges, what we have kind of encountered, and what's our analytics data platform, vision look like, and the architecture. And yeah, we'll deep dive onto the self-service ingestion, how we are leveraging the Airflow orchestration tool, and key takeaways from that. So I think you would have seen similar kind of a slide where how every company try to evolve around the data engineering side of activities. So we also started with a data warehouse where we had our Snowflake just as a data warehouse, mainly having the structured data. But then as our data was evolved because of a lot of 3D modeling and other stuff, so we had structured, semi-structured, unstructured kind of a data. So that's how we had to evolve towards the data lake. And then again, we saw a combination of warehouse features and the data lake features. That's how the lakehouse, kind of evolved as well with all the features and capabilities of warehouse and the lake. And lately, you heard of the data mesh architecture as well, which is talking around domain-oriented decentralization of data, coined by Mac, Degani, sometime around 2019. So that is where we are more focused on currently, where we are trying to build a self-serve and then, self-serve-based ingestion as well as governance around that as well. So that's a key takeaway at this point of time, how we are trying to drive this. So what are the platform challenges when we were trying to build, right? So we had a lot of products, like as I said, Autodesk has, hundreds of products internally. And then all of these data was sitting in silos. So every product was trying to build their own data engineering set of a platform, which was very difficult then to manage across the products as well. So that's where the need of a platformization was necessary for us. Scalable infrastructure as well. Like we have, kind of a 3D data or structured, unstructured, everything. So if all of this data need to be moved on to a central data lake, and each of the products, if they had to build their own kind of a platform, it was very difficult to manage. That's how the platform version was needed. And then, we can scale up and down as and when needed. Again, the data quality perspective is, so we have all the raw data coming in from different sources, which I'll try to talk around next, but then do all of the cleansing, process it, and then moving the data. If every product has to build their own set of, data engineering activity, it would have been challenging as well. So that's where the necessity of a platformation was needed there. And partner onboarding and unified data pipeline management. So currently, all these partners are our Autodesk users themselves. And when they have to, create their own pipeline, they have to go through multiple requests and then, onboard them and have those pipelines being created. So that needed to be seamlessly driven from the self-serve side of it as well. And then ease of data access across, whether it is machine learning or deriving insights, reporting, all of those things. A central way of platform is needed for us. And of course, the custom DAX. So if you have certain customization needed on top of the pipelines, whatever we have created, and then, that can be plugged onto our standard DAX. So that was not possible before. So with the self-serve mechanism and the platform version, we're able to achieve that as well. Specifically on the pipeline side of it, so our pipelines, when we have to create these pipelines, currently partners were used to coming to us with a request via Slack or an email, and then we have to build those pipelines. It would have taken at least 15 to 20 days to create those pipelines with all of the discussions around, okay, what kind of data you have, where do you have that, where should I move all of that data? So all of those discussions would not be needed when we build a sensor because they themselves are aware of capturing all of these details by themselves. And then there is a visibility of all of these pipelines now with the, if you didn't have sensor-based mechanism, kind of collecting all of this information, how the pipeline status are present, all of those would have been difficult as well. And also, if you want to update any of the pipelines, again, you need to go through the similar request, call out a data engineering guy, ask him to update, all of those pipeline configuration details and all. And at each step, we needed a data engineering guy to support all of our partners in terms of dev, stage, or production level, and then create all of these pipelines as well. So this is our platform, how we are trying to put it across. This is driven around the data mesh architecture, as I said before. What we have is a lot of data coming from our Autodesk product itself. We have application level, we have services level, and then a databases level as well. And then we have second party and third party kind of a data like Salesforce, ServiceNow, all of this as well, right? And once we have all of this data, which needs to be captured onto the data lake side, we needed to have some foundational capabilities as well. And on top of it, all the ingestion and processing is supposed to take place. So as part of the foundational capabilities, we have built, the data processing side of activities around ingestion, orchestration, and processing. And storage perspective, we have S3 as a data lake, Snowflake is there as a data warehouse as well currently, and data marts as well, we have it. And perception perspective, we have discoverability, exploration, cataloging, and standards perspective, data modeling and data products, again, driven via data domains. From the operation point of view, building the data portal itself and the access management, quality, notifications, and cost management thing. So once we have all of these capabilities being built, then we have the pipelines itself where we are having both near real time and then the batch kind of a ingestion and processing. So it takes care of both streaming and batch ingestions and processing. And then finally move all of this data to data lake. And from there, we can serve all of this data into, insights capabilities where they can build their feature engineering or model developments, model registries, all of that as well. And finally, customer facing product supporting applications, they can derive all of that information on top of it. And then also on the derived views, whatever the data we have on the data lake at the published layer, so that can also be utilized for, making decision-making applications like or insight dashboards or operational dashboards and business tracking, reporting analytics as well. So all of this is driven via our central data lake. So we have 4 quadrants where we are focusing on: build, manage, discover, and access part of it. So on the build part is where we are having self-service ingestion and then, having the interactive querying and transformation. And then on the manage part is where we are having our pipeline orchestration driven via Airflow, and then DQA, quality, and then cost management. And on the discoverability part, we have our data cataloging, which is Athlon tool, what we are leveraging, and then data lineage. And also from access point of view, we have built our own portal again, our access management, our data domain, data management as well. Previously, we didn't have our corporate data lake, which was not completely secure enough, in a way the data mesh architecture is driven. So that is where it is still a legacy for us, but yeah. And also we are having Snowflake at this point of time, but yeah, slowly moving all of that into a data lake, and then along with that data mesh architecture way what we are talking. So how Airflow helped us in achieving our AD vision, right? So at each capability, now whether it's in terms of ingestion, processing, reporting, all of these. So every capability needed orchestration at each of their services level. And then we handled step-by-step flow at the back end. There are a lot of activities where we needed to create a orchestration mechanism. So that's how we leveraged, Airflow. And all of this visibility of the pipelines where our partners can have one point access where they can just view all of those via sensor portal and automate as much as possible on the workflow side, which is very critical part of it from, leveraging Airflow. So we have leveraged Astronomer, which is deployed on AWS EKS cluster. When we have multiple tenants being onboarded there as part of it. And we have also integrated Databand. I think there were quite a few discussions happened yesterday as well on Databand, how it is being used. So it's kind of complete visibility of our pipelines and how the jobs are run. All of that will be leveraged via data band. So self-serve based ingestion. So as I'm focusing more on the self-serve based ingestion and then how we are trying to leverage Airflow and other data engineering tools. So at the outset, on the source side, we have structured, unstructured, semi-structured, coming from first party, second party kind of sources. But then what is key here is the self-serve portal itself, where anyone can just go and log into a portal and then build their pipelines. So you don't need to have a data engineer available for him to help him out with the pipeline creation. It's a simple UI. They can just need to create connectors and the destinations, give all the information of where my source is, where the data need to go on the destination side. So that's how the pipeline configuration information is given. And then it is processed via request and it creates a pipeline. So we don't maintain any files or anything to be there on the pipeline side. It's all going to a database. We have built a microservice architecture here. All the capabilities are driven via APIs, and that's how we connect between all of these services. And on the platform capabilities, as I mentioned, so we have access and discovery, we have metadata management, resource management, data security, data quality, cost management, AMP, AIML platform, and the insights as well. On the pipeline side, we kind of taking care of ingestion and then, flattening, standardization, GDPR, PII, and then finally publishing the data. And as part of that, as I mentioned, both batch and streaming ingestion, we have it. So from batch ingestion perspective, we leverage Airflow as an orchestration, but along with that, we have our PySpark for compute part of it on top of VMware. And then Fivetran, we are leveraging for database to database kind of ingestion, as well as for API based ingestion as well. We didn't have Matillion previously. Then we are moving from there and currently leveraging Fivetran for that. And also from streaming perspective, of course, it's a Kafka Flink based one on the data pipeline. And underneath, it's a Snowflake as a data warehouse. And as I called out, so S3 is where we are trying to drive more S3 Hive based one as a data lake. But then even on the Hive side, we are trying to now explore Iceberg. And because it has a lot of functionality, a lot of other capabilities as well, that's where we are trying to explore even the Iceberg. And then, once we have all of this data, then we can serve our Looker dashboards or AML platform and any other insights which is needed for our partners. So digging deep into self-serve ingestion itself. So as I mentioned, we have our data portal built on React. It's a web application, basically. We are building it on MFE, micro frontends. So all capabilities, what we are talking here, like A&D, catalog, or resource management, or even our own self-serve ingestion, all of these are built as a MFEs. So, they can do a plug and play and then connect between each of these capabilities as well. And then once we have the pipeline request being sent to the ingestion config service, it stores all of that information, the metadata information, onto their own databases as well. Since we are building a microservice architecture, so every service has its own database and kind of have the metadata being captured on their own database side as well. And for that purpose, we needed some of the additional information like resource creations or related to access, domain. That is where Airflow is being used as well, where we can actually, kind of do a scheduling and then make sure that all of those resources are available before we start the ingestion and the processing. And so once we have all of that information, we pass it on all of that information to the batch processing service. The processing service has the ingest, 3 or API or DB kind of ingest DAG, so which is created from the ingestion service itself and then given to the batch processing side. And then they run those ingestion processing jobs on the Airflow orchestration. So currently we have kind of split into 3 different ingestion types. One is the S3 based one where we move all of the files. The other is the API based one where if there are any APIs, we can directly pull out all of that information and move it onto data warehouse or Snowflake. And also the final one, the DB. So where we are trying to move DB to DB kind of a thing. So if I have database, which is SQL or Oracle or anything, so from there, I'll move all of that data into Snowflake currently. And from Snowflake, of course, currently we are trying to move it onto S3 as well as part of the data lake mechanism, but we are also evaluating directly moving it onto S3 directly. So this is our portal, ADP data portal. As I said, so it's all about governance, how we manage the partner's data, which is like a self-governance based and then also self-service based as well, right? So the users can access their data on this portal So we have a Snowflake and Hive resources. So if needed on the destination side, they can go and create those resources as well from the portal itself. And then they can raise a request to get access to a particular database or particular S3 buckets as well. From there, they can serve their purpose. And then we have a AML project registries and data ingestion kind of a request as well, which they can go and create it here. So that's how the portal has been built. It's a self-service based ingestion and governance. So this is the ingestion dashboard. You can see we kind of leveraged a Python kind of architecture where we are trying to build connectors in the destinations. Basically, you create a destination first where my data need to go. It could be either on the Snowflake side as a database, or it could be an S3 bucket and then Hive on top of it. And then once you have the destinations, you can build your connector where you can provide the source information. Okay, this is where I'm pulling the data from. It has to go to a particular destination. And once we have all of this information, all this data go to database in our ingestion config service and then move on to the processing side. So that's how it moves on as a metadata. And you don't need to create any kind of a files, typically how a data engineer creates, and then you leverage for that for pipeline creations. Yeah, so digging deeper into our workflow itself, so we have our ingestion workflow, which is separated into the data plane and the control plane side. So control plane is where all the configuration information we capture it. While capturing all of that information, there are a lot of places where we need orchestration, whether it is creation of the resources in terms of database or tables or the folders for the buckets, all of that thing. And then even to get Snowflake kind of tenants being created, or even if you want to have access related issues where you want to track those, that all served via our Airflow orchestration. Once we have all of this is available on the control plane, we serve all of this information to the data plane side, and that's where the ingestion and processing activities takes place. So ingestion and then flattening, enrichment, AI, GDPR appliance, a DQA, and then finally to a publishing of that data. The publishing of data, as I said, it's going to be either on Snowflake or on S3. So key takeaways, how we're trying to leverage Airflow and how it has been helping. So our AD capability itself, having multiple tools being involved in this data engineering. So it's an evolving architecture, and we try to evaluate over a period of time, whatever new tools come in or new frameworks come in, try to adapt those. That's how the evolving architecture has been over a period of time at Autodesk. Airflow as an orchestration tool has really helped us in terms of covering all of those workflows, which has been automated. And our partners, which are our Autodesk users themselves, they have now seamless access to their own pipelines. You can go and configure those pipelines via the self-serve portal as well. And last, so one orchestrator tool to perform extract, load, and transformation jobs, and also scheduling and ML jobs as well.